Hello, welcome back. Welcome back. It's yellow day, although that's kind of not really, that's like a really pale yellow, but whatever. Oh,
I mean, I have yellow earrings and a yellow shirt and a yellow Gatorade. So I'm winning.
you are. I had to break out the motorcycle jacket because that's the only thing that I have my reflector yellow. So, all right. So we're going to talk about some theorems about polynomials and continue to find methods of finding arrays of polynomials. So let's do that. Miss Young, I believe, actually stated this theorem before. So I'm going to let her tell us about the fundamental theorem of algebra since it's her thing.
I just like to set things up really early in advance.
Yeah.
So basically, the fundamental theorem of algebra just tells us that whatever the degree of the polynomial is, that's going to be how many solutions we have. So it says every polynomial function of degree n, where n is greater than or equal to 1, has at least one zero in the set of complex numbers. Set of complex numbers tells us that could be real solutions or they could be imaginary solutions. There's a little note here reading this for the first time. So if irrational or complex numbers, zeros, exist for a polynomial, they occur in conjugate pairs. So basically, if one of the answers has a square root on it, it's going to have a plus or minus in front of it. If one of the solutions has an I on it, it's going to have a plus or minus in front of it. So you're going to get your imaginaries and your square roots and plus or minuses, which shouldn't be shocking to you because they came about because you took the square root of something, which means you added a plus or minus to the front of it. So if you've got irrational or square root answers, plus or minus. If you've got complex or I answers, plus or minus.
So we're going to get 2i, negative 2i as samples, and 2 plus the square root of 3, 2 minus the square root of 3. Okay, they always got to come in pairs. So, okay.
Now, just to be clear, your whole numbers don't have to come in pairs. If 2 is an answer, negative 2 does not have to be an answer. Right. Just when it has a square root or an imaginary.
Okay, so what we're going to do is kind of build backwards a little bit. I'll tell you a little dirty secret. This is how we make our tests. We start with the answers and like make the problems, okay? At least that's how I do it because I don't really.
100%. Otherwise, you're just like guessing out there in space.
So these 3 zeros, we're just going to go backwards. If 3 is a 0, from which factor did it come? That would have to be x. It would be x. Oh, hey, Mr. Bobby, learn to use your dadgum computer. There we go. So pick up your pen and annotate. It would be x minus 3 goes with this guy right here. Okay? And now the other factors, I'm going to actually use a different color. That's going to come from x minus 2i. And then the other one is going to come from x minus negative 2i.
Gross. Why would you do that?
To remind them of that factor theorem. But yes, minus and negative becomes plus.
Yeah.
So we can erase that if we wanted to and fix it.
And just so you're clear, we understand that you would never have factored to get x minus 2i or x plus. Well, actually, you could use the difference of squares. I don't know. I didn't actually watch the factor video. Did you factor difference of sum of squares?
No, but
didn't.
Okay, but we didn't. So
you probably would have gotten this from taking the square root, or this plus or minus 2i, you probably would have gotten from like x squared equals negative 4. But you can turn it into factors like you see here.
So this is our polynomial, okay? But now if I just go crazy and start multiplying out things here, I'm gonna kind of start regretting my life choices. I wanna be pretty smart about things. I wanna multiply, if I can multiply out things intelligently, then maybe I'll actually not hurt, make my life miserable. So she's saying start with the conjugate pairs, I think. Is she getting there?
Yes.
the purpley one and the green one, because something magical happens when you multiply conjugate. Things start to go away. So I don't like just always be a robot and multiply things from left to right. So I'm going to do x plus, or leave the x minus 3. And when I multiply those two terms on the end, I'm going to get x squared plus 2ix minus 2ix. And finally, minus 4i squared.
Got to remember here, guys, that I squared is actually -1.
So I would end up with a positive 4. I mean, I know I was going to do that, but I wanted you to see it for the time being right now, right? Maybe I'll move us out of the way. So when I subtract those two x's away, I'll have x minus 3. And all I'm going to be left with is x squared plus 4, which if I wasn't smart about this, I'd have I'd have a big monster that I'd be multiplying out. And then when I distribute that out, I'll get x to the third minus 3x squared. It feels weird to write in green.
I was kind of surprised you stayed in green.
I got off in it and forgot to change. So there's my polynomial. There's a polynomial of degree 3 that has those 3 zeros. And that's exactly what Ms. Young and I do when we make our tests. We start the answer. Not only when we make our problems like this, we get a test question and we have the answer key already. So beautiful, okay? So now the only problem with this is like, that's not the only polynomial in the whole world that would have those 3 zeros. I could have had another factor on there and have a higher degree polynomial, or I could have had a leading coefficient. I could have had crammed like a 6 in front of the x minus 3 at the beginning and have a GCF.
Just, multiply this whole polynomial by 2, every single term in it. Guess what will happen?
So
nothing.
They still have the same zeros, it would just be stretched.
Right.
That's what would happen, but it wouldn't affect the zeros. So I don't worry about, anything else. If I ask you to do it, make your life easy, okay? All right, let's try another. All right, one that I tried to do a million times ago because I can't figure out my draw tool today. Okay, so we wanted polynomial of degree 4, and let's read through this. We have 1 as a 0 with multiplicity 2. What does that mean?
That means that x is equal to 1 for this problem 2 times.
So I'm going to have x minus 1 and then another x minus 1. And if you wanted to say x minus 1, the quantity squared, you go right on with your bad self, but I got to distribute that puppy out, right?
Yep.
And I'm going to have x minus 3, okay? And that one has multiplicity 1, so it's not going to happen again. And what's my other 0? X minus 4. So I'm going to have to, negative. So I have to do minus and negative. And so Miss Young doesn't yell at me again, I'm going to say minus and negative is already positive 4.
Yeah. And really quick, kind of backwards fundamental theorem of algebra here. If we're looking for a polynomial of degree 4, if we're looking to end up with x to the 4th power, we want to make sure that in the prompt we have identified 4 separate solutions so that we can make sure that we get 4 factors that multiply out to get x to the 4th.
And in the interest of time, I'm going to get x squared minus 2x plus 1, right?
So this time he did just go left to right. Because there were no conjugate pairs. And if there are no conjugate pairs, you're probably not going to find a shortcut here. So he's multiplying the first 2 together, and at the same time, he's going to multiply the second 2 together, and he's going to end up with 2 trinomials.
And I don't really want to end up with 9, but you would,
right?
You could figure this out if you really wanted to. Okay.
So now he's being lazy. But you can distribute, 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 distribute.
I know that I'm going to get x, okay? So you really want me to do it all, or are we okay?
You're okay. You don't have to.
Okay. So, I mean, it would be a lot of fun, and you can.
It would be a lot of fun.
Okay. So, all right.
If we were sitting in a classroom with you right now, he would have made you do that and probably turned it in because he's
I
mean.
made you do it, and I would have sat there and had a cup of coffee.
Right. And he wouldn't have done it on the board with you. He would have just said, okay, now turn that in.
All right. Wow, you make me out to be horrible. All right, I'm not that mean. We're not actually, again, there's other ways of multiplying these things out, or there's shortcuts to multiplying it out. We can do technology to do it. All right, anyway, so, all right, so we're not actually going to find the degree of polynomial 6, but we do want to find the conjugate pairs. So I want to make sure you understand this idea of conjugate pairs. So if we have -3 minus 2i as a 0, what is its conjugate pair?
Remember, the plus or minus would only be in front of the imaginary term. So it would be -3 plus or minus 2i. So your other term would be -3 plus 2i.
And I've seen a lot of students change that negative in front of the 3 as well, make everything positive. Okay. I guess I need to get back to my pink. I just can't live with this green. You really need to think of this one as 0 plus 6i. That helps me. I don't know if that helps you, but it helps me because it's always that square root part. Remember, I is actually the square root that changes signs. So really, this would be 0 minus 6i. And then afterwards, I would erase the 0 so nobody knew I actually did that. Okay? I don't want Miss Young to know I have to put the 0 there.
Yeah, I'm quite judgy. Yeah.
She's pretty judgy. She's like my corgi. She judges.
Ooh, did I just get compared to a corgi?
2 square root of 3.
Yeah.
Okay. I should find that meme about corgis. Anyway, I'll put that in another lesson. Okay? All right. Moving on. So we're going to do that with, now we're going to do what we did earlier, but with the complex number or imaginary, so or square root radical or complex number solutions. So we want to find the polynomial of lowest degree. It doesn't specify the degree now, but I know I'm going to have some things to figure out here that has zeros, negative square root of 2 and 2i. Now that rational coefficient is what's going to happen when we multiply it out. We'll see. That means our coefficient, our polynomial should have integers or fractions as their coefficients. Okay?
No more imaginaries, no more square roots.
No more imaginaries, no more square roots. So if we know that -2, these are 2 of our solutions. So using what Miss Young likes to do, we want to write down our zeros. So I know that x equals the negative square root of 2 is a root. But because it's a negative square root of 2, I also have to have the positive square root of 2 because of the conjugate pair. Complex or radical solutions always come in conjugate pairs, right? And then if x is equal to 2i, what is the conjugate pair for 2i is negative 2i. Do I have to have any other solutions?
In fact, you shouldn't, because it says lowest degree.
Mm-hmm.
If you put any, you could put more zeros here, you would still have these solutions, but every time you would add a solution, you would be adding, ooh, I forgot my eye here. You'd be adding a degree. So because the instructions specify lowest degree, don't add anything else besides what you have to.
So when I multiply the first pair of conjugate pairs, I would get a square root of 2 times x and a negative 2 square root of x, or negative square root of 2x. But those would subtract off. That's the beauty of conjugate pairs, right? And I know Ms. Young's probably mad because I went ahead and wrote the square root of 2 squared, but I did that on purpose. You're going to get the first term squared minus the last term squared, right? Every time you multiply conjugate pairs. So when I take these two, I'm going to get the first term squared, which is just x squared, minus the second term squared, which is 2I squared. Okay? And then I'm going to get x squared. What's the square root of 2 squared? Oh, yeah.
About 2.
About 2. And then what's 2I squared?
About 4I squared, which is negative 4.
Okay, but I got a negative out front, so that's going to become plus 4. Did I do too many steps in one?
No, it's so funny because there's so many ways you can do this. I'm about to confuse the whole situation. So in my head, and I feel like there's some people out there worthy of this quick conversation, I would think about this as x is equal to plus or minus the square root of 2. And then I would square both sides of this, and I would get x squared is equal to 2. And then I would think about subtracting the 2 over, and then my factor would become x squared minus 2, sorry, I lost my pen there, is equal to 0. And then there's a 0, so there's a factor. And, you know, just thinking about getting this a different way, there's that.
Yeah, and that would have taken you straight to that step. And if she'd done the same thing with 2I, x equals 2I,
Right.
And giving her the other factor. So I did my algebra in the steps above, and you wrote out the factors, the linear factors for me. So yeah. I don't care how you do it, you know, and neither does Miss Young, I think. So now to finish this up, I'm just going to distribute these two binomials at the bottom, and I'll get x to the 4th minus 2x squared
plus 2x squared
plus 4x squared. Shouldn't it be my when I do?
Oh, you're not skipping that step. Sorry.
Well, I wasn't done. Thank you. Sorry. Yes, the answer is positive 2.
Yeah. I thought you were going to skip that step. You skipped it in all the other parts.
No, you were to the answer. Sorry, my bad. X to the 4th plus 2x squared. This is what she was saying. Minus 8. There's my polynomial. Yep. All right. Sorry. Yeah, that's what happens when I try to not skip steps and not skip steps. You can't read my mind.
I can't. I try, but I can't.
We're the same colors all the time, but you know, we can't read each other's mind. I wonder if they even notice we're color coordinating. They probably aren't, and they weren't listening to this video.
I feel like they should appreciate the aesthetic.
At least the attempt, even if our yellows don't align. All right. So I think I should pick my mouse back up. All right. Last theorem I think in this section is called the rational zero theorem. I can give you the zeros, you can give me the polynomials. In the previous section, I gave you a hint of a zero. I told you one. But if you don't really have a clue, you don't want to be picking numbers out of thin air. Okay. And the rational zero theorem gives you a way to pick logical candidates. And you can read that as rational zero, fraction, the numerator, the constant, the denominator being the leading fraction of the leading coefficient. What? Okay, that doesn't make a whole lot of sense to me. Like it does now because I'm a math teacher and I kind of can read it. So Miss Young's going to kind of help us walk through this. What we're really going to look at is all we really need to find candidates. We need to look at this number and this number. Okay. We want the factors of the constant in the top. So what are the factors of that constant? What are the factors of -3? What numbers could I use to multiply -3?
1 and 3.
1 and 3. But I also could get their negatives, right? So I'm going in the numerator, I really only need to worry about plus or minus 1 or plus or minus 3. Those are the only candidates that I'm going to really worry about for the numerator. And then in the denominator, I'm going to take the factors of the leading coefficient, which are plus or minus 1 or plus or minus 2. Oh my gosh. So I just want to rank those out. So if I take 1 and 3 and divide it by 1, what am I going to get? 1. What if I take 1 and 3 and divide it by 2? I'm going to get 1/2 or 3/2. And then I have to do combinations of their pluses and minus. This could get real ugly if I gave you like, 24 that has lots of ways of dividing it. So I'm probably not. It's really nice when those numbers are prime or small. Okay, so I'm going to get plus or minus 1, plus or minus 3, plus or minus 1/2, or plus or minus 3/2. And those are all plus or minus. Okay?
Yeah.
And
And
that's
just so we're clear, like that's how you find them, but what you're actually finding are possible solutions. And I know he's been saying this, but I just want to clarify it. We always want to have a method to solve every equation. The problem is when these polynomials get long, where there's no way to factor them, like grouping doesn't work, that kind of thing. You need a second method, right? You need something else to go to. And we have no polynomial formula. What we have is the rational zero theorem saying, like, if one of the solutions is a real number that is rational, it will be in this list.
it has to be one of these 8 candidates. If
Right.
I don't exhaust all 8 of these and I do synthetic division with all 8 of these and none of them work, I'm out. Okay. But probably the problems we would give you, one of them would work. and I'm probably going to be honest with you. I'm hoping I wouldn't make it a fraction. Okay. I'm not that mean. I mean, I'm kind of mean, but I'm not that mean. Okay.
I would give you a half, just so like I would think nothing about making you test a half.
I'm not that mean. I am, but not that mean. So, all right. So let's do, I guess we have one more where we would try told 0, but there's something, this is the one that we want to look at the calculator, right?
I thought there was one where we're actually testing. Go back. Did you skip a problem?
There's the
There's
rest.
that. What's the next one?
Wait a second. That's this one.
The
one we're looking on.
Here's the one where we're testing, right?
Yeah, I shouldn't have even had 2 here.
Yeah.
I shouldn't have had that there. Make you find your own, but dang it, I guess I copied something in there. But what would be the candidates for this? Just so we could.
It would be plus or minus factors of 18, which are 1, 2, 3, not 4, not 5, 6, not 7, not 8, 9, and now we're halfway through the number, so we can stop.
Yeah. Well, we could have had 18.
Oh, hello. How about itself?
Had 18.
All right.
And because there's no leading coefficient other than 1, all of those divided by 1 are still themselves. So those 12 candidates would have been the ones I tested. So I think I probably should have taken that 2 out of there just to make you find it. But oh well, you. So we would have tried 1. If I were doing this problem, I would have tried 1 and it wouldn't work. And maybe I'd have tried -1 and it wouldn't work. Then I'd have tried 2 and be like, ooh, it worked, and then I'd be okay. All right. So.
And you'd be happy, but with 2, because that would take you down to x squared, which is going to be solvable. We have methods for that.
So we're going to do 2 in the box and do the synthetic division like we learned in the last section. -2, 9, and what, -18?
Mm-hmm.
And let's do the synthetic division. So I'm going to put 2 there, which will give me 0, which means 0, give me a 9, give me an 18, and give me a 0. Right? So I'm going to now I factored my polynomial x squared plus 9 times x minus 3. That's what p of x is equal to.
Now you're taking it a step further. In the last section, we just said, hey, just factor it and stop. So now we don't want you to factor it and stop. We want you to actually find the zeros. So now you're going to take those factors and set them equal to 0 and actually find the zeros of this polynomial.
So I'm going to get plus or minus 3i.
Yeah. So.
Now that's the other 0. I already was given 1.
Yeah. And guys, this is why I like to go back to list out your zeros and then go back and check your fundamental theorem of algebra. So you're told that 2 is one of them, and you just found -3i and +3i. And then what was the degree of this polynomial? It was degree 3. So fundamental theorem of algebra tells you you should have 3 solutions. Did we find 3 solutions? Yes, we did.
I didn't want him to be blind. So.
Nice. I like him.
So, okay. Last problem of this one. Now, this one, we don't have any candidate given. So what possibilities are we looking at here? Well, let's start with 9.
So 1, not 2, 3, not 4, 5, 6, 7, 8, but 9. Over
1. I'm not so mean, but I could put a 2 there. I wanted to put more there, it would be fine. So I'm going to try 1 and see if it works. And if it doesn't, then I'm going to try 3 and then keep going. So let's try 1.
And for time's sake, while he's trying 1, I'll try -1.
Okay. Yeah, you would just exhaust these numbers. So what do we got? 1, -4.
Oh, I just remembered our synthetic division bars look different. I should have done this like you do it.
Well, and the book does it different from both of us. -4.
It's hard for us to make side commentary though when we're both working. It's just like this weirdly quiet moment in the video.
Mine didn't work. Yours didn't work. Dadgummit. So there goes the 1s. Okay. Now we would do it again with 3. Okay.
Now, remember what we're trying to do, guys. We're trying to find a remainder of 0 because that tells us it's a 0 of the polynomial. So when we're saying it doesn't work, we're looking at that last number. And if that last number isn't 0, we got problems. He's moving faster than me.
Wait a second, did I goof up? That's -2. That makes that -6. That makes it -3. Hey, mine worked.
And I'm kind of quickly, and this will happen, guys. You're going to quickly see when something doesn't work. Like I'm at 28 now. That's not going to work. Like, so I know this just isn't going to work. But if I wanted to keep going, I could, but I'm going to get this huge number, right? 20, 40, 60, 72, negative style.
Yeah, and it's just going to get worse.
Yeah, so that's out.
All right. So I at least found 1. Okay.
Yeah.
And now I've got it down to a cubic, and I could do it again looking at the -3. Now I have to test 1. I'm going to be looking at this -3, and my candidates will be 1, -1, 3, and -3, and do it again. But let
me just say that, like, he's going to this leftover polynomial, right? Because we should be able to factor that guy now. But once we see that this constant -3 doesn't include the 9 that the original one did, that's going to get rid of 9 for us. We already know that 1 and -1 don't work. We already know that -3 doesn't work. So now we're just left with 3. Can 3 be an answer twice?
I don't know. We could do the synthetic division if you didn't have an arrow where I needed it.
My bad.
So if I take a 3 and put him out front, I'm going to try it again with this polynomial. 1, that would put me 3 there. 1.
Now, just to be clear, we've seen when a number is an answer twice, right? We called it multiplicity 2. And look at that. You got a remainder of 0. We're happy again. So these solutions, these plus or minus solutions, we're saying, okay, well, there are, 6 possible solutions, but really we could just keep repeating those solutions. So there's actually, it becomes crazy to think about.
And if we look at the graph of this, I've already made the graph of it.
And we're not going to erase the work because we still need that.
We need the work. Yes, we will not. We'll come back to it. Just so you can see the graph, I went ahead and made the graph of it. You can see that the graph is touching at x equals 3. This would be the efficient way to really do it, is to look at the graph and say, huh, it looks like it's crossing at 3. Let me test 3 and see if it works. And I can tell that 3 is actually, if it works, it's probably going to work twice because it bounces off at 3. Okay.
And that we know that the other solutions, the other two solutions, are going to be imaginary because it's only touching the x-axis at that one spot, right? And then you got that wiggle up above the x-axis saying, okay, that leftover solutions are going to be imaginary. So what we're going to do now is we're going to take this polynomial. Are we going to put it in factored form, or are we going to go straight to this x squared plus x plus 1? What do you want to do?
Well, I'm going to write it as x minus 3
squared.
I already know that at 3 and 3 is an answer. My other polynomial is going to be x squared plus x plus 1. And I'm going to say that doesn't factor, or maybe I don't think that's going to factor. I could try synthetic division with 1 on it and see if it would work. It's not going to.
Yeah, and we know it's not going to because we just looked at the graph and it didn't cross or touch at 1.
So if I have, now I've got it down to a quadratic that I don't have, I can't factor. So what do we do with a quadratic we can't factor?
Well, we know A is 1, and we know B is 1, and we know C is 1. So how about we just go straight to the quadratic formula?
So we would do -1 plus or minus the square root of 1 minus 4. A times C is 1, right?
Yep.
And over 2A, which is 2. Oh no, I got imaginary solutions. And that we saw because the graph never crossed the x-axis again.
Yeah.
So my answers would be -1 plus or minus I square root of 3.
Right, because what you end up with underneath that radical is -3.
Yeah. And that's the other two solutions that will go in the blanks. Okay.
Remember, always go back to that fundamental theorem of algebra. You want to make sure that you have the appropriate number of solutions to go with the problem. It's a really easy way just to check to make sure that what you're doing even makes sense.
And because this is a 4th degree polynomial right here, we know we are okay because we've got 4 solutions. Okay?
Yeah.
All right. So I think that's all she wrote for this lesson. There's a bunch of problems for you. That's a lot of work. I'm not sure I want to erase it, but I'm going to. That's sadness.
And you already had to erase some of it. That's a whole page worth of work.
I mean, like, yeah, when one of those problems you might not want to, we have like this much piece of paper left. Get a new piece of paper.
Yeah. My daughter like squeezes so much work into this little tiny space. I'm like, oh my God, kid.
But, you know what? If you're that desperate for a sheet of paper, let me know. I'll hook you up. All right. Bye, y'all.
Bye, you guys.